ওয়েট করবো আরো যাই করো না কেন আমি কিন্তু 10টা ক্লোজ করব বাস কথা শেষ।
স্যার আমরা আর 5 মিনিট ওয়েট করি।
ওকে নাদিম শুরু করব
জি স্যার, আই থিংক উই শুড স্টার্ট স্যার।
because already 22 students have come. Okay, so we have already started the computation for the half wave rectifier, the last class. And if you remember, if this L is equal to 0, I'm doing it. So the first half cycle, the dioide will be turned on, then this will not be turned on, it will be turned off, and the current will go this way. So this is ID. So IS must be equal to ID, and this is the constant value. So that has been plotted here for the positive half cycle. And since this one is open, of course, your output for the VS must be equal to VT must be equal to VS. That is why, of course, we shall get that using like this. And for the negative half cycle, so since we have provided a path, so this diode will be automatically turn on and it will be turn off, and then IS current will be 0 because this is turn off. IS current is 0, and the current will flow like this. ID current will be as usual, and since the diode will be conducting, it will short circuit, and then the voltage of the diode will be switching. Right? We have covered until this one, and then if this is your output voltage just like half wave rectifier.
Sir, your voice is coming too low. I mean, it's
Is it coming too low?
yes, sir. Not quite audible, sir. If it
Okay, let me change the problem of like. Is it better now? Hello?
Yes, sir.
yes,
Now it's better. Sir.
Okay, because of the internet, this is the problem. Lot of people are some now in internet. I was in link 3, and also I have turned off the fan. So now if it is shorted for the negative half cycle, and you should get the 0 voltage, right? And this, if this Vs equal to √2 Vs sine of omega t, then what will be the average value of this? This will be the half wave rectifier. We should take this pi. This is a twice pi. And if this is your √2 Vs, √2 Vs is nothing but your Vm dt. So what will be the average value?
0.45
Yes, good. This video O means LS equal to 0. This is 0.45 base, right? We have already learned these things in our last class. Am I correct or not?
Yes, sir.
Okay, good. Now let us go down and see. They have just described all these things. Now, if the LS is there, then what will happen? Suppose we have already done. I'm just repeating, okay? Those who have forgotten, so they can always remember this one. This is your LS and this is your VS. So this will be your VLS. And of course, the current ID is here. This is ID2, suppose, and this is your ID1. And the current, we have seen that IS was like this pi and this one, and IS equal to, of course, ID1. Because look here, ID1 is nothing but IS here. Okay, if LS is not there. Okay, so if I plot ID2, then we got ID2 was there. It has taken the current, and this value we can do actually capitalize it. So the shifting of the current from D1 to D2 is done instantaneously. There is no delay, right? Yes or no?
Yes, sir.
Okay. Now, suppose if LS is there, then will this current go to 0 instantaneously, or it will take some time?
It will take some time.
Yes, because inductance has the property to oppose the rate of change of current, so there will be some delay. So if I apply the Kirchhoff voltage law here, then ID Kirchhoff current law, ID2 equal to your capital ID. Suppose for the example it is 10 ampere. So when the current is, say here 10 ampere, ID1 equal to 10 ampere, ID2 must be equal to 0. Here, if I plot ID2 here, this is pi, right? 0. And then it is decreasing, right? Suppose it is, say, in the middle, ID1 equal to 5 ampere. Then what should be your ID2?
5 ampere.
5 ampere. 5 plus 5 must be equal to. So when it will reach to, say, 10 ampere, ID2 equal to 10 ampere. All current is being now carried by ID2, then what should be the value of your ID1? 0,
0.
right? So, okay. Now, we see that before omega t equal to 0, which diet was turning on? Before the omega t equal to 0. That's here. D2, right?
Yes.
Then IS was 0, right?
Yes.
Here. Suppose here. And it is going down like this, and it will go like this. Okay. So when during the commutation, when one diode is losing the current, another diode is building the current, and here at the omega t equal to 0, D2 is losing the current, D1 is building up the current. So during this commutation period, omega t, both diodes are conducting, right? But look here, both diodes are conducting here. Am I correct or not?
Yes, sir.
Okay. So now, if both, particularly if D2 is conducting, then what should be your output voltage? Taking the output voltage.
So when D2 is conducting, output voltage shall be 0.
Okay.
It will short.
Yes. So suppose it is U. Of course, you should get 0 voltage here. And after that, when D2 stop conducting and ID1, that means D1 got the full current and constant current, there will be no drop here because VL equal to say LS DIS by dt. If IS equal to capital ID, of course, VL will be 0. So look here then, if this got the full current, and of course, when the current will be 0, this ID2 will be 0, like here. Look at this figure. And this voltage is also 0. Why this voltage is 0? It is mentioning here. Look, why the VL is 0 when this is open, fully open? Why VL is 0? I have already told. Tell me why VL is 0.
Just to constant pulse.
Yeah, it got the constant voltage, yes, current, right? So there will be no change of current, and VL will be 0. So if so, then what will be output voltage or output voltage? If this diode is open and if this voltage is 0, what will be your output voltage?
Supply voltage. BS.
Supply voltage, okay? So it will be like your supply voltage, good. And this is your pi. And after that, like here, again, D2 is on, and it will be on for the next up to twice pi, right? Up to twice pi. So here, of course, here, if it is pi plus u, D2 of course is on, and even after that, pi plus u to twice pi, D2 should be on, right? So during the commutation period, okay, D1 and D2 both are on, 0 to u, and even after pi to pi u, we see that this one is on, and after that, of course, here it will be on. So our output voltage wave shape will be like this, and this is your twice pi, and this is your pi, and this is your 0. So we have lost this area. Did I derive the area, equation of the area in the last class? Hello?
No, sir, I think.
You think? You don't have any class note or anything, right?
So some portion of it was covered, but not totally, I think.
Okay. So now we want to find out And first of all, we want to find out the wave shape of the output voltage that we have already found. And we want to find out the area because clear this thing. This is your, oh no. This is your U. This is your U. So this portion will be your U. And we have lost this area AU, right? So if we don't lost this area, what will be the output voltage we have already calculated? 0.5 VSI. But because of the presence of this source inductance, we have lost this area AU. So we must make negative. And what is the unit of AU? Can anyone tell me? The master's student or PhD student. What is the area of AU? Sorry, unit of AU.
A square.
This is the voltage and this is radian. This is volt and this is radian. Area is nothing but the what? Volt multiplied by radian. It should be volt radian, right? Is it not?
Yes, sir.
It's volt radian. But what is the unit of VD?
Just voltage.
Voltage. This is in AU is volt radian. So we have to get the average value of AU, to get the average value of AU, say V average we want to find. What should we do?
Divide by 2 pi.
Divided by twice pi, right?
Yes, sir.
Because our time period is this one. So we must find out the expression of AU. And also with that one, we can probably find out the expression of U. I am trying to do that. Okay. Suppose here this circuit, commutation is going on. Commutation will be going on during this period. Commutation. You understand commutation? What does it mean by commutation?
Sir, when conduction changes from one or a set of diodes into another set of.
Yes. Shifting of the current from one set of diode to another set of diode, or one diode to another diode, right? So, and that is being done here, as we have already mentioned. This is ID2 is your ID2 is just going down, and this is your ID1 is going up, and this is your commutation. So during this commutation, that this circuit is valid, then if we apply the Kirchhoff voltage law here, what will be the Kirchhoff voltage law? Vs must be equal to
VLS.
VL. Then they put VL. Vs equal to root 2 Vs sine of omega t, and VL equal to Ls dis by dt. Right or wrong?
Yes, sir, you're right.
I am correct. Okay. Then Ls dis, if you multiply this one this way, so that will be your root 2 Vs sine of omega t dt. Can I write this?
Yes, sir.
Can I multiply this both sides by omega? Then root 2 Vs sine of omega t. If I put this omega inside, can I write this way? D of omega t is nothing but omega dt. You got my point?
Yes, sir.
Okay. So now the operator on the left hand side is current and the right hand side is angle. If you say yes or no, then how can I know you're listening?
Yes, sir.
Okay, so, and also then omega ls dis. I'm integrating with respect to u, this part, root 2 vs sine of omega t, t of omega t. What is this? U. Is it not the area?
Yes, sir.
Integration.
Yes, sir.
So this is the area AU. And we have to, of course, if you integrate the right hand side, you have to also integrate the left hand side. So this is the operator, this is omega t. What is this operator? Yeah, change of current. So what is the current at omega t equal to 0 of is, if you remember that? Is equal to ID1, right?
So, yes.
Yes, sir.
What is the current here?
0 current.
0, sir.
0. Okay, put here 0. What is the current at omega t equal to u?
So IDs.
ID, sir.
Capital ID. Okay, ID. Now, if you complete the equation, that will be your ID, and that will be also AU. And if you do this integration of root 2 VS, then 1 minus cosine of U, that will come. You can check. Okay.
Yes, sir.
Okay. Then your 1 minus cosine of U will come as omega ls ID divided by root 2 Vs. And look here, this is AU equal to this one. Okay. Then if you want to find out the expression of cosine U, it will be 1 minus omega ls ID divided by root 2 Vs. This will be the expression of the commutation angle with respect to omega ls ID and RMS value Vs. If you know omega, if you know ls, if you know ID, if you know Vs RMS value, you can always find out your U commutation angle. And also you have already found the AU equal to omega ls ID for half wave rectifier. Now we have already told that the average value VD will be your 0.45 Vs minus AU by twice pi, right? Then it is coming as 0.45 Vs minus omega ls ID divided by twice pi. You understand it or not?
Yes, sir.
Yes, sir.
দেখে আমাদের ইয়ে আসছে নাকি কি নাম জানি সঞ্জয়দা
Yes, sir.
Sanjida has come, okay. কই গেল? Okay. Today Abdullah, did you come?
Yes, I'm here, sir.
Okay, so you don't make any sound. How can I know you have joined?
My classmates are making sound, so we are following.
Okay, okay, good. That's good.
Yes.
Okay, let us know there. Okay, that we have already found here. Look here, the VT is this one, area this one, and we have got this, and this is this one. And what is the voltage we have lost? Average head of this voltage area divided by twice pi. This one, right? Now, if I ask you the question, if LS is increased, whether your voltage average value will be same or decreased or increased? This average
Sir, will decrease, sir.
Decrease.
So it depends on the frequency as well as the source inductance and also output current. So this is for your half wave rectifier. Now we can analyze the same thing for the full wave rectifier. What is this figure?
Full wave rectifier, bridge rectifier.
Full wave bridge rectifier. Good. Okay, good. Now there is an LS, right? Okay, let us first plot the input voltage. This is your pi and this is your twice pi, and of course this is your omega t. Axis is omega t. Okay, so for the positive half cycle, which diodes are supposed to be turned on?
Q1 and D2.
Suppose L is equal to 0. First, let us see L is equal to 0. So current will go like this. The current will go like this. And this. D1 and D2, right? Right or wrong?
Yes, right.
Yes, sir. Right.
Okay, so IS will be, look here, IS will be your capital N. If L is equal to 0. Okay, good. Change the color. This is your say IS. And also this is ID1, ID2. That means this that. Okay, for the negative half cycle, then D1 and D2 will just stop conducting. And since we have the path, we are still considering L is equal to 0. Then this is your negative. Then current will go, okay, this way. Change the color. The current will go like this, and this should come here, and that should be D4, and it is going to the opposite what we have got. So what should be the wave shape of the IS then?
Square waves, sir.
Negative.
Negative waves.
So can I write down this way here also before the omega t equal to 0? Here actually this is your, here ID3 and D3 and D4 will be conducting during this period, D3 and D4. When this period D1 and D2, right? Yes or not?
Yes, sir.
Yes,
This
sir.
is the, okay, let me draw here. Suppose this is your ID1 and this is your ID2, and this is your ID3 and ID4. So this is this one. And this is this one. So now look here. Because of the presence of this inductance, whether the current will build up instantaneously, or it will, there will be a delay.
There will be a delay.
There will be a delay, sir.
That should be a delay here. And during this one, as I have mentioned to you, of course, this current must go down, right? This current will build up and this current will go down. So now during this commutation period, which diode should be conducting?
All of them.
All four diodes.
All four diodes will be conducting, D1, D2, D3. Okay, good. And we have already plotted the IS without LS or LS equal to 0, we see here. But if there is LS, so this IS will, if you plot here, if you plot this one, because this one will be going like, and this one will be falling like this, and then this one will be nothing but The wave shape will be like this. ISO wave shape will be like this. Trapezoidal type. Okay. Now, so the current at omega t equal to 0 was what? IS current. What is the current at omega t equal to 0? If I consider here, 0. 0? This is the current. IS current. This is your 0 axis. This is the 0 axis. What is this current? What is this current? Minus ID. So what should be this current? Minus ID. What would be this current?
Plus ID.
Plus ID. So IS current is changing from minus ID to plus ID during the commutation period omega t. And here both all diodes are conducting. All are conducting during this commutation period. You got it?
Yes, sir.
Okay, now. If so, then during the commutation, we want to find out again AU. Oh, okay. What will be the output voltage? If there is no LS, the output voltage will be like your full wave rectifier. Am I correct or not?
Yes, sir.
If okay, so what will be the average value?
Point 0.9 VS.
Good. Who is telling this one?
Sir, I'm Ahmad Shafil Basri.
Okay, from which university?
Sir, IIT, sir.
Good. Okay, if there is no LS, you will get this one. But since 0 to U, all diodes are conducting. If all diodes are conducting, let me clear this thing. Understand this. If it is shorted, if it is also shorted, because all diodes are conducting. If this is shorted, what should be the VD? If this, what should be the VD?
0 voltage.
0 volt. Good. So then you should get the 0 volt here. And after that, when D1 and D2 got the full current, D1 and D2 got the full current, what will happen to your D3 and D4?
Open,
It
sir.
will start-
Disconnect.
Disconnected. And then since this current is constant, what should be the voltage here?
0.
0.
Same as before. And then your VD will be your VS, right?
Yes, sir.
Sanjayda,
Yes, sir.
it will be like this. And same thing will happen for the negative half cycle. Here, all that will be conducting, and then rest of the time D3 and D4 will be conducting. So if I plot nicely here, this is pi and this is pi, we shall get the output voltage like this, and we shall get the output voltage like this. So we have lost this area, AU. Okay, during the commutation period, we want to find this AU. If you apply the Kirchhoff voltage law again, same as before, your VL, and then VL will be ALT IS by dt, and root 2 VS sine of omega t, and multiply LS, right? It is DIS, and that will be your. Now I am audible,
Yes, sir.
Yes, sir.
Yes.
clear,
Yes, sir.
no lagging.
No, sir.
Okay, good. So we are now integrating 0 to U. So that will be a T of omega t. So you are integrating this one 0 to U. It is nothing but the area. Am I correct or not? This area.
Yes, sir.
Okay, so that will be also area AU. And you have to integrate this. So what is the current at omega t equal to 0 here?
Minus ID.
Minus ID.
Minus ID, I have already told you. And that should be a plus ID, right?
ID.
And then your AU is coming as 2 omega LSID, not single root here. For the half wave rectifier, we got only the single
Yes.
omega LSID. Here now 2 omega LSID. And the rest of this one is same as before. Okay, this one is this one, then we
Same.
integrate this one. 1 minus cosine of u, right?
Yes.
And there should be root 2 Vs. And then cosine of u will come as 1 minus 2 omega LSIT divided by root Vs. Only difference with the half wave rectifier is that now for your there should be a multiplying factor of 2. We want to find out the average value of the voltage. Vd will be 0.9 Vs minus the area AU divided by now what? 2 pi or single pi?
Pi.
Hi, sir.
Single pi, because it is repeating, right? Repeating.
Yes, sir.
This is your pi. This is your pi plus C. So you have to. Now it is 0.9 Vs, then 2 omega LS ID divided by pi. Is it clear to you, everyone?
Yes, sir.
গা গুলাইতেছে আব্দুল্লাহ, এই আব্দুল্লাহ,
Yes, sir.
গা গুলাচ্ছে, what does it mean?
বুঝি নাই।
গা গুলাচ্ছে, গা গুলাচ্ছে, মাথা ঘুরছে।
Oh,
মাথা ঘুরছে মানে কি?
you have headache?
Headache is better than your মাথা ঘোরা. You
Oh,
understand what happened today? So there was that rehearsal meeting that continues up to almost 4:30 from 2.
wow.
So this is the thing, it has been given to you. And don't go to the book. They have made it complicated. Finally, they got this one. Can you see it? 5.32.
Yes, sir.
Yes.
Now, so you don't use any class note, right? Are you? No.
I don't use personally.
Good. Dhruvo,
Yes, sir.
we have
I have-
class note used for. Do you have the class note? Okay, good. Now, solve this problem. Half wave rectifier with finite LS. That means LS is equal to not 0. Okay, let us plot this. Now this is not sinusoidal rather than rectangular type things. This is your Vs and this is your Vs. This is 100 volt and this is your minus 100 volt. Okay, and LS equal to say 5 millihenry. Then this is your main diode D1 and this is your freewheeling diode D2. And this is your load current ID equal to say 10 ampere. What is U and what is VD? Do it. First, you draw the output voltage. What should be the output voltage? Half a rectifier. Okay, if there is no ALS, what should be the ratio of the output voltage? Tell me.
So same as the only half of the input.
Like this, right? And this will be a 100 volt, and this will be a say VD. This is VD. Okay.
Yes, sir.
Okay.
Yes, sir.
because of the ALS, we will lose some area, right? AU. If I plot here, this is a price pi, this is a pi, and then there will be a delay, loss of area here, loss of area. If it is U, sorry, if it is U, no, not this one. This is okay, this is pi. If this is U, and this is 100 volt, what is the AU? By trigonometry. What is the area of a rectangle? Height is given, and also base is
2
given,
into 100 U, sir.
100 U. And for the halfway, we have already got this one, right? Can you remember?
Yes.
Yes or not?
Yes, sir.
Everyone.
Yes, sir.
Yes, sir.
Yes,
U
sir.
equal to then this one, IT divided by 1. Suppose F equal to 50 hertz. What is omega? Rubo, what is omega?
100%.
2 pi F,
F.
340 Newton. So I learned it, say, almost 40 years ago.
Yes,
I
sir.
know that for 50 hertz it is 314, and for the 60 hertz this is 377. You are always using the calculator. 314, L is equal to how much we have taken? 5 millihenry. 5 into 10 to the power minus 3. ID equal to 10, and then divided by 100. So this one will be in what? Degree or radian?
Radians.
Will be radian. Now, this is the voltage actually we got in one cycle, right?
Yes.
What is the, so then what will be the
Sir, pi
Available-
minus U into 100.
area set B?
100
B by twice pi or single
twice
pi?
pi, sir.
Twice pi. So this area B will be, as he mentioned, pi minus U divided by twice pi. So you must calculate your U from here and you substitute here. If you put U equal to radian, then you can always use twice pi and pi. If you use degree, then pi should be 180 degree and twice pi should be 360. Result will come same. Okay?
Yes. Yes.
For the full wave rectifier. Say ID equal to 10 ampere. So this is your D1, this will be your D2, this will be your D3, and this will be D4. L is equal to same 5 millihenry. This is like same thing we got here. Again, find U equal to what and VD equal to what. This is your input voltage, 100 volt. This is your minus 100 volt. This is your PS. Okay, if there is no ALS, what should be the output voltage?
Same as the input voltage.
This one, and this one will come over there.
Sorry, DC voltage of 100 volts.
Something like that, right? Yes, it will be 100 volt DC. But because of the presence of LS, then what will happen? You will lose this area, right?
Yes.
And this is your pi, and suppose this is your twice pi. And here also you will lose this area, pi plus u. And then this one. And you will again lose this area, right? Twice pi. This is your twice pi plus u. So actually we got this value, pi to this one, and this will be 100. Then again, what will be your AU? Same as before. What will be your AU?
100 U.
100 U
100 U. And that will be your
twice omega LSI.
twice. Yes, for the full wave, be careful, it will be 2. And then you find the U here. And what will be the average value of VD then?
So 100
100 pi minus U divided by pi.
This will be your,
Pi minus U divided by pi.
okay. Then VD will be then 100 pi minus U divided by pi. Everyone got it?
Yes, sir.
Yes, sir.
Other people.
Yes, sir.
So you have to find the U from here. So for your masters, normally I make your life very tough in the exam. So instead of putting very simple square wave, sometimes I put this one like this. So suppose this is 100 volt, suppose this is your 200 volt, something like that. This is your pi and this is your twice pi. And this is your minus 100 volt and this is minus. Will you be able to do it?
Yes, sir. We just need to like look at the rectangles. I mean, we just have to
Yeah.
subtract the first rectangle, then add the rest of it.
Your output will be, it will be the mirror replica, right? So then how it will be look like? This one, the last one, this one, and then it will come like this.
So it will be just 100, 200, 100, 200, just like steps. I mean, 100, 200, 100, then again 100, and then again just
Like this,
Yes.
right? Okay. You're very smart. Hmm. Oh. It is a, I don't know whether you use this Wacom or not. It will be like this, right? But we lose the area again. Suppose this is, did this depend on the LS? Okay, let us assume that this will be like this. And same way, if it is 100, then your 100 U will be your 2 omega LSIT. And your, this will be your pi. And you have to get this one also. It must be given, right? It must be given to you. It must be, suppose it is say twice pi by 3. Suppose this is your twice pi by 3. So then you have to, what would be your average value of the output voltage? First of all, twice pi by 3 minus U, then multiplied by 100, right?
Yes.
Yes, yes or
Yeah.
not?
Yes, sir.
Then pi
Pi
minus
minus cross pi by 3 into 200.
200 and divided by pi. Okay? Yes or not?
Yes, sir. Yes, sir.
So now you'll be able to do it. Okay, let us go for and start sharing the book. It is given here. Now we'll learn is if there is a constant voltage at the output. Okay, let us see the circuit. Circuit is this one. Okay, will you take any break? What is the time? What is the time? 9:24. That I will continue inshallah up to 10. So let us take a break of 5 minutes, okay?
Yes.
Then we can come back, and it may not take up to 10, but let us just, let me take 5 minutes break. I am getting older, man. So you have to consider this one. From 9:30, inshallah, okay?
Okay,
Okay.
sir.
আমি শুইলাম। ভালো। একটু ভালো, ক্লাসে কথা বলবো, হ্যাঁ? Okay, I'm back. Hello,
Yes, sir, I'm here.
other people? Oh,
Yes,
they
sir.
are here.
Yes, sir.
All are here.
Yes,
Now
sir.
we are thinking about a particular case, like a constant voltage source, and other than a constant current source, we are thinking a battery charger like things, and also LS is there. So this the equivalent circuit has been given here. So look, because eventually, since this is a full wave rectifier, we should get something like that. With that consideration or any other consideration, they are thinking like, okay, they are taking the mod value of it and analyze this one. Let us see. So look here. So you understand, right? This is your mod value of the VS. This one. Mod value they are thinking like this. And there is the VD is the source voltage. What we have already told you. This is the VD. The VD is the source voltage. And source voltage has been drawn here. Understand that one. And since this is your VM, this is your VM. If the source voltage is greater, this is the VD. This is your VD. If VD is greater than your VS, so there should not be any conduction, right? Okay, let me draw the figure. I will do that understand. So this is your D1 and this is your D2 and this is your D3 and this is your D4. This VD source voltage is always reverse biases these two diodes, right? Because this VS is less than your VD. When this voltage VS crosses, then only D1 and D2 should start conducting. You understand it or no?
Yes.
Yes, sir.
So that is the beginning point, and it should start conducting like this. And the crossing point of VD and ED, there should be the peak value, the same as before. What we have already know that VS will be your VLS plus VD. So when VS and VD equal, then VLS will be your 0. VLS can only be 0 when the current will have the peak value. We have already discussed this thing, right?
Yes, sir.
So this is your beginning of the current, and okay, we are thinking that this is the discontinuous mode of operation. That means the value of LS is not that much that you will get the current like this. It falls down theta F. F is the final value. Theta B is the beginning of the current, and theta P is the peak value of the current. Now we want to find out the expression of ID. Because already you know the output voltage, right? What will be the output voltage if we take the output voltage here? What will be the output voltage? It is already VT, right? There is no need to analyze this one. Rather than we have to find out what will be the average value of the current, what will be the peak value of the current, what will be the final value of your angle that current is conducting, what will be the beginning. Can anyone tell me what will be the beginning angle? At the beginning of the angle, √2 Vs sine of omega t, that must be equal to Vd. Am I correct or not?
Yes.
From there, theta
Yes, sir.
B will be a sine inverse Vd by √2 Vs. So you know you can find out always the theta. Then we have to find out theta f and also what will be the p. That is our main question today. No. Yeah, fine. Okay. And also, that is your average value. They have, if this is the current wave, sorry. If this is the current wave shape, if this is your current wave shape, there might be average value. We can find it out. And what will be your VL? VL is nothing but L di d by d. So as long as this is positive, slope is positive, you have the positive here. And after that, peak value slope is negative. So this area A might be equal to area B. We have already discussed. Did we discuss that thing in the earlier class? Hello?
Yes, sir.
Yes. Okay. ঘুম পাচ্ছে নাকি তোমাদের? Are you sleeping? Are you
No, sir.
sleeping?
No, sir. So you have discussed it in earlier classes.
Right. Okay, now let us start how to find out the angle of all these things. First of all, as I have already mentioned, from here you can find out theta b will be sine inverse by dt by root 2s. You can use this equation to find out theta b. That's done. Okay. Next, we want to find out the theta p. What will be the peak value? That we want to find out. What will be the peak angle? Sorry, what will be the peak angle? Where the current has the peak value, that we want to find. So, how can we find out? It is very easy because from the trigonometry you can see that. This is the, look here. This is same. If you know theta b, then pi minus theta p will be your pi minus theta b. You understand it or not? Like if there is a sinusoidal, this, if you know this is theta b, then can you find out this angle?
Yes, sir. Pi minus theta.
That they have used. So that theta p has done, and then we want to find out the equation of the current. We want to find out this equation of the current. So when the current was going on, then our equation will be your Vs should be your VLS plus Vd, right? So then from there, LS ID by dt will be your Vs minus Vd. Then LS dID will be your Vs minus Vd dt. Then if you multiply by both sides omega, then this is your root 2 Vs sine of omega t minus delta Vd and d of omega t. Then you are integrating to 0 to theta. Also here, or theta b, sorry, theta b to theta. That we want. What is the current at theta b?
Sir, ID.
Hey, look here.
Sir, 0.
Zero.
So omega ls 0 to theta, say, then did will be your theta b theta. Theta means we are just putting the general equation. So this will be your then id theta, right? Id theta will be you just integrate it and then you put your theta b and this theta. And finally, we'll get the equation of the ID as this one that we have done. And finally, we'll get this one, right? That we have already, I have shown you. ID theta will be a, well, this omega ls has gone to denominator, theta b 0, and then root previous sine of omega t minus vd df. So if you know theta b, then you can always find out the expression of ID theta. Am I correct or not?
Yes, sir.
How can you find out the say theta f
So simply putting ID equals to 0 in this equation, then finding
equal
out.
to 0, and then you find out theta b, theta f. You know theta b, and you know all these things. Sine of omega t minus vt and d of omega t. Because current as at the final value is also 0, right? With that one from your equation, the number 4 article, you can always find out the value of theta f. And it is nothing but the corresponding of your area A and area B. You can check. So if you know the equation of your ID, if you know the equation of ID, then you integrate it to find out the area theta b to your theta f and divided by the pi, that will be your average value. You understand it? This is nothing but the area under the curve. Suppose this is your theta p and this is your theta f. You find out the area and divide it by the total time period. You understand it? Hello?
Yes, sir.
Okay. So that will be the average value of this. And with that one, there is a problem actually inside your book. You can see it at the end of the chapter. Okay, then they have to normalize this on short circuit current. What will be the short circuit current? It is intuitively obvious for a given circuit, ID will depend on the value of the VT and vice versa. Okay. To present the relationship between two in general manner, we normalize VT by VTO and ID by the short circuit current. Then ID short circuit current will be where ID short circuit, how this one is there? Short circuit current can come. Why? Okay, let us again draw that. The simplified one, right? This is yes. Then if it is shorted, yes. What will be the value of your short circuit current? The load is shorted. What will be your I short circuit? Apply the Kasher voltage now. So then take the highest value, right? VS. VS what? VS is the RMS current. Okay, let us see. Where this one will be the RMS current that will flow if the voltage source VS short circuited through your LS. That means this VS is short circuited here. And following the above procedure results, I'm just showing what they are trying to tell you. We have just plotted this one. This is nothing but the ID divided by the short circuit current in the y-axis. In the x-axis, they have taken the VD by VD is the original voltage, and the VDO, if there is no LS, then they have plotted this one like this. So if you increase this one, and eventually the current, the ratio of that will go to 0. I did not study much about this one. You study it. Okay. And then, but it is not difficult. If you don't understand, of course I can help you. So this is the rectifier characteristics. Okay. You try to understand this one: total harmonic distortion, reflection power factor, They have plotted all these things. Inshallah, from the next class, we shall start from this article, practical direct bill rectifier. We will make that equation, all these things, matrix, and then we will solve this matrix equation, and there is a problem, and we shall discuss all these things. Okay? Today, what is the time?
Sir, 9:45.
9:45, a lot of time. We have taken a lot of classes. We don't want to take more classes. Oh. Stop here. How many students are there? So all students are present, except probably one. Okay. Savik did not come today, right?
Yes, sir. I talked with him. He said he's sick today, sir.
Okay. So that is the reason, except Savik, all are present. Okay, then goodbye. Assalamu alaikum wa rahmatullah.
Alaikum salam.
I am ending the session, okay?
Walaikum assalam, sir.
Good.